Hi students, today we are going to dive one level deeper into the ocean, into the Black Abyss. We are going to read about hot vents and frilled sharks, searching for new species. We are now on our fourth layer down from the ocean, from the sunlight zone, the twilight zone, even darker the midnight zone, and today, the Black Abyss. We will read pages 20, 21, 22, and 23. Let's skip ahead. All right, here we go. Students, this is our fourth day reading the book, and sometimes I've noticed that this book follows different rules than we normally see in texts. Normally, in reading English, we start reading at the top of the page from left to right. This chapter, The Black Abyss, starts on the right page. I can tell because the text here is really big. That shows me that this is the title of this chapter, The Black Abyss. I'm thinking of these pages as more of a poster than a book because both pages are about the Black Abyss and the author wants us to start here. Let's start reading. The Black Abyss. The abyss is mostly a pitch-black, icy zone, but life still exists here. And where the ocean floor lies close to inner Earth's hot magma, hydrothermal vents occur. Discovered only in 1977, about 50 years ago. These vents teem with creatures that, amazingly, survive the most hostile conditions. The animals that live here have many adaptations that let them survive. In areas with these hot hydrothermal vents, students, very close to the Earth's hot magma. That is a mouthful. The Frill Shark. The frilled shark is rarely seen, but we know that its eel-like body is about 6 feet long. It catches prey half its size with 300 needle-like teeth. It is named after the 6 frill-like gill slits at the side of its head through which it takes the oxygen. Here we can see the gill slits. That's how the shark breathes. It takes oxygen from the water. See-through creatures. Translucent, stalked jellyfish live mostly near the shore, but new species have been found clustering around dead hydrothermal vents. Stacked jellyfish move more slowly, just shifting their position slightly. They are hard to spot as their color is adapted to blend in with their habitats. A tube worm's blood gives it its red color. Interesting. Giant tube worms. This is another creature that lives in the abyss. These bright red translucent creatures live around the chimneys of warm hydrothermal vents. They have no eyes, mouth, or stomach. What? Wow, how do they survive? Tube worms use energy passed down by bacteria that live on them. The bacteria take in the chemical hydrogen sulfide from the vent, and this keeps the tube worms alive. In turn, the bacteria live on the tube worm's blood. Interesting. So even though the tube worm does not have eyes, mouth, or a stomach, it survives on the energy it receives from bacteria. How interesting. One moment, students. My dogs are playing. Gilda, Biscuit, out. Out, please. Go. Go play somewhere else. Go. Oh, dogs. All right, let's move on to this page. Smoking chimneys. Hydrothermal vents form on the ocean floor above hot, moving magma. Magma is another word for lava. Lava comes from volcanoes. There are underwater volcanoes in the ocean. Cracks in the ocean floor allow seawater to seep in. This water is heated by the magma and bubbles up again. The boiling water brings with it dissolved rock minerals that harden into a crust and which builds into chimneys. This is a hydrothermal plume containing oxygen, sulfur, or acids. Here's a picture of a hydrothermal vent. This information says the temperatures reach between 122 and 752 degrees Fahrenheit. To put that into context, the hottest days in Minnesota can reach just over 100 degrees. So this can reach almost 8 times as hot as it can be here in Minnesota. And that's in the middle of the ocean, thousands of feet down. Chilled out. In the Gulf of Mexico and away from the warm vents, a species of polychate, I'll have to look that up, worm or bristle worm lives in chilly methane ice burrows. Very cool. All right, the secrets of the abyss. The abyss is so far down. We learned on the last page that it wasn't really discovered until 1977. That there are still many secrets down in the deep, dark ocean. To explore the abyss, scientists use state-of-the-art technology to map the hidden crevasses, monitor important global currents, and look for new marine species. The discovery of hydrothermal vents, see the last page, also revealed deposits of precious minerals such as cobalt and gold. The Gulf of Mexico. This is a hot spot for scientific research because of its deep sea habitats, from coral mounds and glades to salty pools and expanses of mud. Here's an image of a boat mapping the floor. The boat is sitting on top of the sunlight zone and is attached to some technology that's down on the ocean floor. That is the Black Abyss. Oceanographers survey the seabed first by using the Global Positioning System, or we call it GPS, and official Coast Guard coordinates to record their position. Echo sounding equipment profiles the undulating ocean floor. Digital hydrophones convert sounds into electrical energy, which can be measured at the surface. This is similar to echolocation that is used by many animals, including bats and whales. Underwater robotics. Robotic submarines controlled from the surface explore and record conditions in the abyss. Some grab samples to bring it up for research. Others use fiber optic technology to capture 3D videos and still images. Microphones pick up such sounds as whale songs and volcanic eruptions from the ocean floor. Oh my goodness. Students, you may read on to learn about the ocean currents, how the water flows, and useful venom. I wonder, how could venom be helpful? How could it be useful, full of use? When I think of venom, I think of an insect bite or something that's bad. I wonder how it could be helpful. Remember to answer the questions today about our reading.